Good afternoon, everybody. So let us start our lecture today. Today is September 9th. So we are discussing linear time sorting algorithm, right? So last week, so this week, in our last lecture, I gave an overview of the linear time sorting algorithms. There are three linear time sorting algorithms that we discuss. One of them is counting sort, right? That is the foundation or base of linear time sorting algorithms. Okay, counting sort. And then we have radix sort, and see the radix sort algorithm is just one line of code. It asks us to use a stable sort algorithm. That is, it refers to the counting sort algorithm. Okay, and then bucket sort algorithm, it is kind of linear counting sort algorithm. Okay, so we will recap this again today, and then maybe I gave you a task, homework, maybe not homework, task to read this. How many of you had a chance? Did you have a chance to read this?
To read the counting sort? Yeah, I read.
You understand?
Yeah.
Okay, that's good.
But were we
Did
supposed to read the other sorts or just the counting?
If you, this is the foundation, this is the base.
Okay.
If you understand this one, then other two are easy.
Okay.
Okay.
That's good.
Did you try this one?
Yeah, then you mean the counting sort?
Yeah, this like, for instance, in your test, I will give you some data like this. Okay, and I will ask you to complete this chart. It has some missing parts. In your test, you have to complete this. But in order to do that, you need to understand this. Okay, the book, it has a little bit complexity. The first time if you read it, if you do not give more attention, then maybe you will see that this algorithm is counting some algorithm. It is not that much bad. Okay, so this algorithm is applied over here. Okay. So give attention. I will explain it, and then after that I will give you some task to do. Okay, make your paper ready and give attention, please. If you understand, then you will be able to do the task. Okay, so this is a given data set. How many data elements? 8 elements, right? 25302303. These are, let us consider that these are just numeric numbers, nothing else, just numeric numbers. Okay, so then we need to sort it, right? We know some sorting algorithms already, but we will use counting sort algorithm. The terms it refers count. The algorithm itself is about count. So what do we count from here? The easiest thing, simple thing is that we will count the number of occurrences of each element. These are called key elements or the given element. So how many 2's are there? We see that one and this one and this one, right? There are 2 2's, yeah. Right? Okay, and how many 5's are there? 1 5. How many 3's are there?
3.
1 2 3. And how many 0's are there? 2. And we already counted 2. We already covered 3, and we already covered 0, and we already covered 3. Right? So actually, in order to count this, we need another array, a subsidiary array we need. Okay, that array, okay, this is the subsidiary array called C. Whatever you give name, C or count, whatever you give, that doesn't matter. But the array is C. Okay, this array will size it. There are some conditions. There are some properties, fixed properties to this array. This array, it will have size. The size will be the highest number, highest element in the given array plus 1. Its size must be 1 more than the highest element. What is the highest element? 5, right? There are 5 elements in this. We intuitively we see 5 elements, right? If even we don't know it, if it is a large number or very large set, right? We can do a single for loop to find the largest number, right? To maximum number from a loop, from an array, we can run one for loop, right? To get the highest number. Searching algorithm takes linear time algorithm. It's proven. Okay, so then this array, that is the maximum number. This k, we will say that k. So in our program, we will say that k is the highest element in the given array, the largest element. Okay, and for now, let us consider that these numbers are numeric numbers, whole numbers, and they are positive numbers. There is no negative numbers. There is a way, if there are negative numbers, we need to do some extra operations to work with negative numbers. But for now, just consider that all these are non-negative. It can be 0 or positive. Okay, then k will be the highest element of A. Okay, then we will create an array with size k plus 1. So here give me one second. Here k will be the max of A, array A. So we can find it, right? 5. Okay, then we need to declare an array C its size with size k plus 1, that means 0. Let me put on top 0, 1, 2, 3, 4, and 5. This is k plus 1, right? 0 to 5. How many elements? It has 6, right? K plus 1. Okay. Then initially, we initialize all of this C initialize with 0 values. It's easy, right? In one loop, by running one loop, we can declare an array. Okay, in one statement, a simple statement, and we can assign all values to 0 by running one for loop. So this part is linear, this part is linear, right? This part linear, this part linear. Okay, so this part linear, this part linear. Okay, now we need to update this C. We need to update C with the number of occurrences of each given element. Okay, that can be also done in linear time, right? We can search each element of this given array and check for how many 2's are there. Okay, how many first element, if there is a match of, okay, so you see that from the book and our coding there is a difference, because in the book they have declared this array with index 1, but we usually declare an array with index 0. this is the confusing part. Some student may get it. So if you say 1, so if you write in program, actually you need to put 0, 1, 2, 3, and all the last element will be 7.
Why is one indexed correctly but the other isn't? Like that's.
Okay. So in the book they wrote in pseudocode. In pseudocode format they use index. We start with index 1.
Yeah, but the bottom one starts with 0.
The bottom one they did it. They did correctly. So they could do it.
Well, why would they do one correct and one?
I don't know. This is my that was my first question when many years ago I wrote this.
like it's so inconsistent.
Yes, so inconsistent, and the confusing part for this one. Now this is why I tried to give you some hard time. Maybe it's like I asked you to read this. If you read it, then you got the, since you read it, right? So you got the complexity. If you did not try, then you think that, oh, it's very simple. Actually, it's not. Okay, so I'm rearranging this. Okay, so the code need to be rearranged if we put do this. Okay, now what we will do, we will update this array, this C counting array, with the number of occurrences of each element. Okay, that can be done in linear time, running a single for loop. Okay, so that is the value they got already. Okay, I will show you the code is simple over here. Okay, so okay. This is the initialization. This is the initialization. Okay, initialization. This one, here initialization. Okay, I'm sorry, I'm messing because if I keep this here, that will be a problem. Let me move it a little bit up. Okay. Now here, this code is to update this line number 4 and 5. These are to update the C. Okay. For j equal to 1 to length, from here starting j, this array, they are starting this array. Okay, C of a, so this one, what does this one means? C of a j. Okay, if j equal to 4 equal to 1, so if I go with this code at j equal to 1, what is a j? A1 equal to what? 2, right? Then 2. Then if I say C of 2, forget about this. C of 2, initially it is 0, right? C of 2 initially it is 0, right? And then equal, this one will be, I could write in one line. Plus equal to 1.
You're incrementing it by.
I'm incrementing by 1, right? So that means this one C of 2 will be, initially it was 0, right? Then this time it will be 1. Okay, then incrementing j by next one, so j will be 2, right? So then a of 2, next time a of 2 will be what? A of 2, 5, right? A of 2 will be 5. Then C of 5 equal to what? C of 5 initially it was 0, right? C with C array with index 5, then it was 0 and that will be incremented by 1, so that will be 1. and then again we are incrementing j by 1, then we are going 3, then a3 equal to, now a3 equal to, let me write it down, a3 a2 equal to 5, a3 equal to what, 3, right? a3 equal to 3, then c3 equal to, initially c3 equal to 0, right? So that will be incremented by 1. Okay, and again a4 equal to 0. Okay, then c of 0 will be incremented by 1. C of 0, this one will be incremented by 1. And then let me do the next one. a5 equal to 2. Let me see then this one, if you understand this one. a5 equal to what? a5, we are counting only the inner part. a5 equal to 2, right? a5 equal to 2. Then c of 2 equal to, c plus equal to, c of 2 we are incrementing by 1. What was c of 2? Already 1, right? We are incrementing by 1, so that is getting another one, plus 1. Then we are getting 2. Okay, so if you run all the way, so until the length from 1 to length 8, then you will, this counter array will be updated with the number of occurrences. Okay, and here if you use in a program code with index 0, then you will start from 0 over here, and then you will go to a dot length minus 1. Okay, in a program code, right? If we start from 0, then we will start from 0 here, and then it will go length minus 1. That is the difference, okay, in program code here. So now we will get by doing this way. Okay, do I need to complete the remaining part? You understand, right? How to complete this C? Okay, at this point now we got C. This way we will got C. Okay, now this C contains, is almost done. It is almost done. If these data values are just numbers, numeric numbers, then it's done. You can see that in the final array, we can see that there are 2 zeros. How do we interpret this? There are 2 zeros. There are 2 zeros. Okay, no 1. There is no 1. There is no 1 over here. 2 twos. 2 twos. Okay, and then 3 threes. 3 times. You can say times. Okay, and how many? There is 4. There is no 4. And how many 5s? 1 is 5 1 times. I did a mistake. I did a mistake. This will go. This one will come first. I did a mistake. Let me write it down. It says 0 2 times. 0 2 times. Okay. 0 2 times. 1 0 times. 2 2 times. 3 3 times. And then 5 1 time. And other numbers. Okay, the missing numbers 1 and 4, we don't need this. The 1 0 time, and then 4 0 time. Okay, we don't need to consider 0, the values that are zeros over here. Now if these are just numeric numbers, then we are done, right? So if we get this information, so right, then we can show that there are 0 2 times. That means in our final array will be 0 0, and 2 2 times, then 2 2, and then 3 3 times, 3 3 3, and then 5 1 times, 5. Then that is done. This is my output. We can easily write a program, right, to do that. If we have just with a single for loop, right, we can write that the 0 0 2 2 3 3 3 5. This is our output, 0 0 2 2 3 3 3 5. Maybe this could be a very the simplest sorting algorithm if the number are just numeric numbers. Okay, but we are considering this algorithm. This algorithm is developed as, is called what is the word, in place or stable algorithm. This algorithm is considered as a stable algorithm. Okay, what is mean by stable algorithm? I'm coming. And in order to make the stability, in order to ensure the stability, there are the complexity, these lines. So this part, these two parts, this is the additional part. We need this.
Yeah, because the equal numbers won't get swapped, right?
Yeah. So for instance, instead of these numbers, if not numeric, if these numbers denote something else, for instance, number of accidents, if these numbers comes from a data set that denotes the number of accidents for some auto insurance holders, customers, right? If the insurance company wants to give some incentives, some discounts, right? So if this number 0 means there is no accident, 0 means no accident, is 2 accident, 2 accident, 3 accidents, 3 accident, 3 accident, not tickets, 3 tickets, and then we have 5 tickets, right? So then if they want to give, okay, the priority, again another priority, who comes, who applies first will get the service first. First come first service, right? In that case, we need to know the priority. Maybe so this is John's record, this is my record. Okay, okay, so there are two people have the same number of occurrences, but they're not same person.
So yeah, I was reading the book, and
Yeah.
it's like talking about it's important for satellite data. Like what is?
That needs an order. That comes with an order. Priority or order. It comes with an order.
Okay, so like with the element, there's extra data with it.
No, what time it is coming? What time it is coming? There is timestamps.
Okay,
With
so
it.
satellite data means like timestamp.
With timestamps
Okay.
or something. It means something else, not simple data.
Okay.
Right? Because these data values are associated with something else. Like for instance, the number of occurrences or tickets, right? So if they say, a company says that if there is no ticket, then we will give some discount in your insurance, okay? Or if they have a deadline to submit your application, right? So that there is then in order to maintain deadline, they have to see who submitted first, right? Or if say that if we will give there are many people have 0 accidents, zero tickets, right? But they will give incentive to limited number of people who comes first or who second, okay? So then people who applied first, this zero means the person who, maybe John, he applied first, okay? And then this is maybe me, I applied after John. In that case, it's not simple. There are these values are not simple, right? Not numeric numbers. Okay. So far whatever I discussed, everyone understand? Everyone understand whatever I discussed? Okay, that I said that if these are just numeric numbers, then it could be done. The algorithm is done over here. But let us think that we need to make this algorithm as a stable algorithm. That means each data set has may have some other properties that we need to consider, or we need to keep the order of incoming order. Okay, then the complexity arises here. Then we need two more for loop. But you see that this algorithm for all of these have for loop, independent for loops, right? So this is why it is linear. There is no internal for loop, one for loop within another for loop. Okay, now let us think that, let us understand what does this two part do. Okay, so everybody understand this, right? Okay, now yeah, everybody please give attention. This part is tricky. Okay, please give attention to me. Okay, now what we will do, we will update this count array so that it holds cumulative sums, cumulative values. So cumulative, this is the one. It start with index 1. Well, I start with index 1. That means the index 1, this one. So the first value will be as is. The C is updating with this. The first value is as is. For the second value, we are getting the first. See that Ci equal to Ci plus Ci minus 1. That means that this value will be updated by this plus the previous value. Okay, so this will be updated by this plus this. Then 2 plus 0 equal to 2. You understand? 2 plus 0 equal to 2. Let me write it down. So these 2 plus 0 equal to, the first one is as is. Okay, then because the array start with, the loop start with index 1, first one is coming as this. The second one is coming a0 plus a1. This is 0 plus 2 equal to 2. The third one will be this 2 plus 2. Okay, the third one is 4. Okay, this one will be, so this one will be updated as, so this will be 2, and this will be 2 plus 2 plus 2 plus 0 plus 2, this will be 4. So this will be 4, and this will be 2 plus all previous, just add, do the cumulative sum. Okay, so then 2 plus, we are already 4 plus 3, 7. The third value will be 7, and then fourth value will be 7 plus 0. This is 7, and the next value will be 7 plus 1. That value will be 8. So this is the updated C array. So this is updated. C. So you do understand? So updated C. What does this updated C mean? This updated C means okay. 0, this updated C means 0, this element 0 will be 0, if there are multiple zeros, we see that there are multiple zeros, will be zeros, okay, whatever it says, zeros will have, if it exists. If 0 exists, then 0 will have the last 0 will be second position. The last occurrence of 0 will be at the second position in the final value. See the last 0, sorry, there are 2 zeros here, right? 2 zeros here, right? The last 0 is this one. Last 0 will be position, second position. So in array, if we start with index 0, the second position is 1, right? This 2 means is critical part over here. So this 2 means if there exists a 0, then the 0 last 0 will be at position 2, and if there exists a 1, okay, the last one will be at position 2. If there exists a 2, then last 2 will be at position 4. So it exists 4, it exists 2, right? So the last 2 has position 4th position. 4th position, how can I get 4th position? At index 3. Don't be misled over here. So not we need to subtract 1 from over here, okay, to get the index. Okay, if there exists 3, the last 3 will be 7th element. The 7th element has position 6, right? 7th element has position 6. 3, 4, 5 and 6. And if there exists a 4, if there exists 4, then that last index will be 7. The 7 last index will be 7 minus 1, 6. The position will be 7. Okay, and if there exists a 5, okay, that index, last index will be 8 minus 1, that is 7, or that will be 8 elements. So it is 6, 7 index over here. So this is 5. Okay, so what we are getting over here from this updated count array, it is telling me that if there exists an element with this index, its index, and this its value will be the position of last occurrences if that exists. But for some cases it does not exist. We saw that for 1 and 4 does not exist, right? There is a kind of complexity over here. Okay. It will happen since if all of these some values are greater than 1. By looking this, some values are greater than 1, so then some values here greater than 1, so it will happen that there will not be some elements, some will be missing. Okay, so far everybody understand how the C is updated and what does this C arrow mean? Yes.
So for C, why did you put the number 3 first?
Why am I putting 3 here in C? Here?
No, the third one.
This one?
No, the right one.
Here?
No.
This one?
Third image with the 2 arrays. You know, he only has a 3.
I don't understand. Which position? In updated C?
I think he means on parts.
Yeah, parts.
Right
yeah.
up here. This stuff here.
Yeah.
Here? Here? Here?
Yeah. So you create a array B, right?
No, I did not go here. I'm not
Oh,
I'm not
okay.
here at this part.
Okay.
I'm considering this part.
Okay.
Just this C. We'll go there soon. Okay, this is the last loop. So my question is, do you understand this? Okay. So this C, previous C was easy, right? To understand, this told us that how many of occurrences 0 times, 0 how many times? It says 0 2 times, 1 0 times, 2 2 times, okay, 3 3 times, 4 0 times, 5 1 times. But this will tell us the last position, the position, okay, of each but with condition if exist. Okay, now the last loop, the last for loop. So you are coming here, this for last for loop. Now what we will do, so far we learned that we need to get the position from here. We will get the position of occurrences of a value from here. Okay, now we need another array, the output array B of same size with the original array A. Okay, and what we will do, so this part, you see that this part is kind of tricky. There are 2 lines, but this is tricky. Let me tell you, let me come from the right side. What we need to go for here, see, we need to start from the given array from right to left, from the end. I will tell you why we need to end, okay, in order to maintain the stability. In order to maintain the stability, we need to go from the last. Okay, so then for this one, for j equal to a dot length downward 1, okay, so here they put the index 1, so this is why, and the last index equal to the length, so this is why they put for j equal to a dot length. But if you write your code, okay, if you write program code, then you need to write if you write program code, then what do you need to write? For int j equal to, help me please, a dot length -1, right? If I program it, so index start with the last index will be size -1, length -1, right? Okay, and this is initial. How long it will go? As long as j greater or equal to, oh I'm sorry, maybe I can write, so this sign is greater or equal to, right? So this one greater or equal to 0, right? And then it will decrement j, right? Downward means j minus. So if you write program code, then you need to write the line number 10 as like this. Okay, so in line number 10, what we are doing over here, we are getting aj. What is my aj value? aj what? J equal to length -1. Okay, the last one, right? We will get the last index value. In array A, given array A, what is j value over here? J is will be number 7, or so then here 3, right? This will be 3. You understand? A is j equal to 3. This is my j value, right? J equal to length -1, the last index. Please give your sound, whether you understand or don't understand. You understand? So I'm getting last index, and the value is ij length minus 1, so value is 5. Okay, so aj should be 3. Did I do any mistake? J equal to length minus 1. Oh, I'm sorry. This is my this is my output array. I need to look at my input array. This is why I'm confusing. This one. We need to consider my given array, right? No, this is our output array, B array. So I should get rid of this. I was confusing this one. We will fill up this array. Okay. Okay, now let us say that this one. What is aj equal to 3, right? The last index, element at the last index, right? This 3. Okay, these 3 will go where? These 3 will go, we have a of j of b of c of b, then there is a minus 1. So if you go with this one, this code, writing, let me explain this code. So if I go with this one, so then I will have length, and then I will have 1. Okay, if I go with this code, then I will have length is equal to a dot length. Length will be here is 7. Okay, 8, length equal to 8, and I will go up to 1, index 1. Okay, then what does it do? B of C of aj. What is aj around here? 3. Okay, then we need here C of 3. C of aj equal to 3, right? aj equal to 3, right? And what is C of aj? C of C, this is my abbreviated C. C of 3. C of 3 equal to 7, right? C of 3 equal to 7. This is 7. And where it will go? At position B, my output array B. So B7, at B7, this 3 will go to B7. See, this is the B array at position 7. This 3 is going to at B7. This 3 is going to be 7, and this is the 7. So this part over here, this is critical. Some of them, actually let me write it down again. So here what it will go, this aj will go, first of all we need to find internal, we'll find one aj, that means we know that aj equal to 3, right? Is equal to 3. It is fine, easy to find that. And then we need to find b of aj. That means b of 3. Okay, b of, oh, sorry, this is not b, c. C of 3. What is C of 3? Now come here. C of 3 equal to 7, right? C of 3 equal to 7. It is giving the index. I told you that this will tell the last position. Okay, this C of 3. So what is C of 3? C of 3, 7. Okay, this is 7. And then what I am looking for, B of 7. So this AJ will go to B7. Okay, that means AJ will go to B7. That means you see that 3 will go to B7. This is why 3 is going to B7. And after doing that, what we need to do, since this array it tells us how many times it occurs, okay, then we need to get the C of 3, this sorry, we need to decrease it by 1. See that C of A is A, that means C of 3. What is my C of 3 value? 7. We need to decrease it by 6. It no longer will be 7. We need to decrease it by 6, because the next time if 3 exists, that position will be 6. Okay, the first 3's position is 7, but if another 3 exists, that position will be 6. That position will be at 6, because 3 is occupied already this place. Yes.
Isn't B7 the last one?
Huh?
Isn't B7 the last?
No, because we started with index 1. See this code, I'm going to this code. According to this code, B7, B8 will be the last one. They started with the index 1. The book started with index 1. But if I write my program code, if you write in Java or C++, in modern languages, then there is a difference over here. What is the difference here? -1, and then it will go up to 0, right? Same number of looping, it will go almost all from last element to first element, but there will be difference over here. What is the difference over here? We need to, let me go with this one. I don't like to mismatch with program code and this code. So let me ask you, everybody understand this? Okay, at some point when the loop will go, this C loop, the value will be decreasing, and then it will be done. Okay, and how many times we will do? As many times as n, right? So going from 0 to last or coming from last to first is same number, n number of times occurrence, right? This is a linear loop. Everybody understand this? Okay, so this is why I say that they put 3 over here, at position 7 they put 3, and you see that there was at index 6, at index 3 there was 7, right? At index 3 now there is 6 changes here. You see that 6 is decreased by 1. Now let me go with this one again. Then what will go? It will come with this element, right? J will be decreased. Okay, J will be decreased by 1. So then next time J will be this one. Then AJ will be denoted by, will be 0, right? Next time will come this element. So that is what is A0, what is AJ equal to 0. Then 0, I'm just removing this, the second iteration. Okay, can I remove this? I don't need this for the second iteration. If you understand 2 or 3, then you will understand all of this. Okay, so let me go to the second one and third one, then you can do manually all of this. Okay, the second one will be A, J will be 7. Here j was 8. First one for j equal to 8, and then for j equal to 7. A7 equal to what? A7 equal to 0, right? A7 equal to 0. Then C of 0. What is C of 0? 2, right? Then C of 0 equal to 2, and this one will go with at B. So at B2 value will be at B2 this position value will be 0. So this 0 value is going to position at 2. But again, so this is index start with the actual index. Okay. But intuitively, if you this one is easy to read. Okay. Then third one, the third iteration. Let us do it manually. Okay. The third one, this will come with 6, 3, right? Aj equal to 3. Then we will go to the position at 3. What is this value? 6, not 7 here, right? 6. Then okay, then it will be changed over here. So it is this one 0. Then it will change to 1. 2 to change to 1. You see that? Okay. And here this 3, for this 3 we will go to C3 equal to 6. Okay, and this 3 will be at B6. This 3 will be at B6. Okay, then 6 will be 5. Another loop, if you come another loop, then Aj will be A5, that means 2, right? And then it will go to the index 2 position, this position 2, and at position 2 it sees that 4. So then this 5, this element, fifth element or 2 will go to the position. What is the position? 4th position. 5 will go to the 4th. This 2, we're coming to here, right? 2 or 0? How many loops we have done? I did 1, 2, I did 3, then this one 2. So 2 equal to, at position 2 it is 4. So then at 4 this 2 will be at 4, this position at 4, this 2 will be here at 4. Okay, and then at this point this 2 will be decreased by 1. So this is done. But if you write your program code, okay, then when you write your program code, then let me erase it. If you write your program code with for this one, then we need to say for int j equal to a dot length minus 1 to j greater or equal to 0, j minus, let me write it down here, j greater or equal to 0 minus. What do I need to do over here? There is a tick over here, so output will be get B, C, A, J. Okay, C of A, there is a mistake. We need to reduce index by 1. this a of j, and then this minus 1, this one will go a j. This is the change we need to do. If you go actual program code, then index, if index start with 0, or this one 0 1 2 7, then we need to do this change. We need to go one step behind in the here. So we know that 7 position means index 6, right? 8 position means index 7. So when you get this value, when you retrieve this value from C, this one is the retrieval from C, then we need to subtract 1 to get the actual position in B. Now if you understand this, now see that the other steps are missing here, right? So in your test, I will give a data set to complete all steps.
So like you gotta show how does it work step by step.
Yes. So now the complexity of algorithm is linear time, right? But there are some limitations with counting sort algorithms. That what did we discuss? So far, what do you remember last time I said, or today I said? This works generally only for positive numbers. Okay, since these numbers, these are associated with index value, right? With the indices for this.
Okay.
So this is we need positive numbers, but there is a way if there are negative numbers. For instance, if one number is negative 3, then you can do it. So you can add 3 to all of them.
So to make them all positive.
Positive, and then finally
subtract.
when you go to display your result, you subtract 3
So
that
there's
number
always a
from.
clever workaround.
Yeah, it's a trick for some kind of interview question, that how can you do that. Okay,
Okay.
if the you understand,
Yeah.
if there is one number, for instance, is negative 5, so that we cannot apply counting sum algorithm, but we can do a trick, right? We can twist the algorithm, right? For instance, at the beginning, if we add 5 to all numbers, then we got all positive, right? Then we can apply counting sum algorithm, and then finally before we printed our result, we subtract 5 from all numbers, then we will get the result. Okay, that is an interview question. That is it possible? Yes, it's possible, but we are not going that trick. Is that what we want to do? So the we is in general we will say that it is applicable only for positive numbers. Okay, and non-decimal numbers. Okay. There is another problem. You may notice, or you may have not noticed yet. Let me tell you. If I have, okay, that we are saying that if I have 2, -5, 3, 0, 2, 3, 0, even -3, then I can convert it to add of -5, right? As I said, 0, oh sorry, -5 plus 5, add plus 5 to all, plus 5 to all elements, then 7, 0, 8, 5, 7, 2, 3 will be 8, 5, 2, and then we can sort it, and then we can subtract. This is a way for negative number twisting, but I'm okay. This case 1, if there is a negative number, okay, case 2, if there is a outlier. L-E-I-R. Outlier. What is the spelling? L-A-I-R. That means there is a very large number. Okay, easy. If there is, easy. I have 2, 5, 3, 0, 2, 3, maybe 0, and then 3,000 or 30,000 or 3 million. Then what is the problem? If I have this data set, what is the problem? One of the numbers is very large, outlier. It goes unexpectedly very large by mistake or something. It can happen, right? Then what is the? Do you see any possible problem?
C will be very large.
Yes, your K value will be 3,000, right? 30,000, right? Maybe 300,000. Okay, then K will be very large, right? And compared to C, compared to given array element, right? We are only 5, 6, 7 elements, but we need to the auxiliary or counting array, that will be C will be need to be size, that means 300,000 plus 1. C will be very large number, right? C will be very large array, and then it will have some empty. So like the cumulative sum, for instance, we say that, for instance, sum here, for instance, after some point, we'll say there will be same value. You see that if there is no occurrence, there will be same value, and all the way end, it has the value. What is that? 1, 0, 1, 2, 3, 4, 5, 6, 7. All the way in, this will have 7. These are the okay. This is 300,000. There will be none at position 7.
So you're handling it.
So that means whatever I say that this array C array will be verbose, right? Very large array, right? So here, then what will be the dominant part for this in this array? In that case, the K, this loop, right? The loop from 1 to K, this one that runs from 1 to K, that will be the dominant part, right? So otherwise, so actually then we see that for this one, for this algorithm, if it is as is with a for a smaller, for K less or very less than less n, K is smaller than n, okay, or pretty close than n, then we have running time over here theta of n plus K. But if K is very large than n, then which one will be dominant? Here in this case, theta n, this is equal to theta of n. This is dominant, right? And for that case, that will be theta of n plus K will be theta of K. K will be the dominating value. But unnecessary, we don't have any we are not actually our goal is not to consider K, because K can be 300 or 30 or even K is, if is the case very outliers, that will be last value, right? No matter for this data set, if K equal to the last value is 30 or 300 or 3000, that will be last value, right? So for handling one data, so we have to compute a lot of operations, especially here. You see that this place, cumulative one, and this array. So that is an issue. Okay, for large K or an outlier. So I don't know if there is a way, if there is a trick to handle that. Maybe the way is that to keep that aside. Okay, keep that aside and put it at the end last. Okay, now does anyone have any question? Yes.
So if the K is bigger, then you would just say it's theta of K, and if the K is smaller.
K is the largest element.
Okay. So that says equal to theta of K?
This one? This one?
Yeah, that's just
Yes.
theta of
If
K.
K is very large, then if K is very large value, then K will be dominant part, right?
Okay.
But in our algorithm, we are comparing size of with the input size,
Okay.
right?
The array size?
Not the no array size. This is the array size.
Okay. That's the array, the
Yeah.
size, and K
Array size is the element, largest element.
Okay. Oh, because that'll be the size of the C array based on
Yes.
the largest element. Okay.
Yeah.
So if you had a very large element, then the runtime would be theta of K?
Because that does not have runtime will be proportional to theta of K, because now it does not have any association with the number of input. If you have 5 inputs, okay, or 7 input or 10 inputs, but K is very, very large, then the K will be dominating. Okay.
And if the array is really big, then the n would be dominant.
Yes.
So
But
like,
generally,
to
in general.
generalize this to either of them, you just say it's the theta of n plus K?
Yes.
Okay.
Generally theta is n plus theta is n, yeah, running time Tn equal to, for this Tn equal to theta of n plus K. Now if you understand this, then the other two algorithms we will apply this. We discussed in our last lecture, right? So how to do this in the periodic sort algorithm.
Does it talk about the positive outlier?
Periodic algorithm, we use a stable sort algorithm. Why it is stable? This is the interview question. Why it is called a stable sort algorithm?
Because the
Which part makes sure that it is stable? I'm giving the code.
lines 10 through 12?
Yes. Yes.
Okay.
Let's have the line 10. Okay, line 10.
Like where in the book is like the positive outlier thing that you're talking about?
Okay. Thank you, everybody. We'll see you next week.